like this. And we have our little trapezoids look like this.
Hi, Jacques and Sam.
Trying to silence Cap.
So this is normally the height, base 1, base 2.
Mrs. Lepp told us to shut up.
What's the formula for... I agree with that statement. What is the formula for area of a trapezoid?
1/2 the height times bracket B1 plus B2 bracket.
What does B stand for?
Yeah.
Base.
Okay, but in this one context, what is the base actually?
Base.
Base. Okay. The computer is froze 777 times. We're starting over. Okay, so here is 0, 1, 2, 3, 4. Shh. So here's our trapezoid 1, trapezoid 2, trapezoid 3, trapezoid 4. Pretend those are the same thing. Okay, quiet. So change in x for all of these, or the height for all of these, is actually the base. So this is h, this is h, this is h, this is h. They all have the same height. So that's why we got the ones for this is area 1, area 2, area 3, area 4. They also have a half because of the actual formula, right? And then B1 for area 1 is f of 0. B2 is f of 1. That's area 1. Then area 2, B1 is f of 1. B2 is f of 2. Then area 3, B1 is f of 2. B2 is f of 3. Then area 4, B1 is f of 3. And then B2 is f of 4. Correct? We have all of our areas. Now, we're trying to come up with how the trapezoidal rule would work if they all have the same change in x. Right? Change in x being b minus a divided by n. And in this case, it'd be 4 minus 0 divided by 4 partitions. So it was 1. Please. All right. So we did get the same change in x. If we don't have the same change in x, we actually have to find each area separately and add them like we're doing above. Okay? If we do have the same change in x, we can actually GCF some things out of here. What could we GCF out of here? And we're including the 1 because it's not always a 1. Sometimes it's a partition of 2. A half and a 1. So we can take out the half and we can take out the 1. Remember, the 1 represents what? Change in x, correct? So we can take out a half and we can take out a 1. And then what are we left with? F0 plus F1 from this one. Then from this second one here, we're left with plus F1 plus F2. Then for this one here, we're left with plus F2 plus F3. And for this one, we're left with plus F3 plus F4, which we can write as 1/2 times 1, f of 0 plus 2f1 plus 2f2 plus 2f3 plus an f4. So do you see how that first and last term are only taken once? Because they're on ends and they don't actually share them twice for each area, right? So for each area, you were only using one value once. But when you have overlapping B1s and B2s, you get them twice, right? So for here, I used this one once, this one twice, this one twice for area 2, 3, this one twice for area 3, 4, then this one once, right? So going back to what the trapezoidal rule said, even though they don't have it, or whoever's watching this has no idea what I'm talking about, because the podcast had to be deleted. Area of a trapezoid. So trapezoidal rule. The trapezoidal rule, oh right, I had a title in the other one. Trapezoidal rule. The trapezoidal rule, which all of you have written anyways, but I'm going to rewrite it again, is from A to B, f of x dx is approximately b minus a over 2n on the outside, f of x0 plus f of x1 plus f of x2 plus 2, yep, good catch, plus plus 2 of xn minus 1 plus f of xn. So how does the trapezoidal rule make sense? Well, this b minus a over n is just change in x, is it not? B minus a over n is just change in x, and change in x in this one that I just did is 1, correct? And then they get a 2 on the bottom because you have to multiply by 1/2. So that's how we get the 2, is because we're multiplying by 1/2, correct? And then here we have f of 0, f of x0, then 2, then 2, then 2, then 1. And that's all this means. Does the trapezoidal rule make a little more sense?
Yes.
Now, you can only use the trapezoidal rule if you have the same change in x, remember? So I said to you that if the first trapezoid was 1 apart, then this one was 2, a distance of 2, then this was a distance of 1, and this was a distance of 3, I would actually have to find all of the trapezoidal areas separate and add them, because their change in x isn't the same. You can only use the trapezoidal rule if this occurs, because here we have this change in x, if it's the same partitions for each one. So if they give you a table of values and ask you to do the trapezoidal rule, and we go from 1 to 3, then 3 to 4, then 4 to 6, then 6 to 7, those aren't the same distance apart, right? So you'll have to do trapezoid area formula. You'll have to use this one. Find each area separately. Now, do you suppose you're given that formula on a formula sheet somewhere?
No.
No, you're not given a formula sheet, so you're not given the formula. So it's one you're going to have to memorize. Could you just memorize the trapezoid formula like Layton already has memorized and then just add them all up? Yes. Same thing. Okay, so I'm going to give you a question. Use the trapezoid rule. I'm going to say using the trapezoid rule. Determine the area where n equals 4. And once again, the more n's, the more you partition it, the more accurate it's going to be, because there's going to be less of that area outside or inside, right? And do you think the trapezoid is going to be more accurate or less accurate than a rectangle?
More.
More for most parts because of the curve. It kind of covers that curve. Not as much above, not as much below. Determine the area where n equals 4 of 1 to 2 e to the x over x dx. So do you actually have to draw it? No. For all of these, at the very least, unless it says you have to draw it, the very least you have to do is a number line. I will always do a number line so that I know my f of whatever's I'm looking for. So I need to do a number line from 1 to 2. Partitioned 4 ways. Well, I can find my change in x, which is actually the change in height for this one, right? It's that h. So change in x is what? b minus a divided by n. So in this case, it's 2 minus 1 divided by 4, which is 1/4. So we have 1, then we have 1.25, then we have 1.5. Let's pretend I evenly distributed these, and then 1.75. And then I should have 4 areas. Do I have 4 areas? Area 1, area 2, area 3, area 4. We'll do these as separate areas first, and then we'll fill in the trapezoidal rule proving that's the same thing, right? And we have proven this before. So what would I do for area 1? I would do 1/2 times what? 1/4, or 0.25 if I so choose. And then what would I multiply by? F of 1 plus F of 1.25. And that's how I would get area 1. And I would do the same for area 2, area 3, area 4, correct?
Yeah.
Do we have to show it that way if we have the same change in width? Could we go right to the trapezoidal rule? Do you want to go right to the trapezoidal rule, or do you want to find all the areas? Right to the trapezoidal rule. Okay. The trapezoidal rule only works though if our change in x is the same, and people will tell me, no, it doesn't work. I filled it in by me the wrong answer. That's because you didn't have the same change in x. That same h on the bottom when we actually take that trapezoid and turn it. So if we want to do, I'm going to show all of them. You don't have to. You guys can do the, just to prove a point, f of 1.25 plus f of 1.5. And then area 3 is a half times a quarter. F of 1.5 plus f of 1.75. And then area 4 is 1/2 quarter. F of 1.75 plus f of 2. So we're going to have to show that. We can do area for the trapezoidal rule, which is b minus a over 2n, right? Or 1/2 change in x, and then fill it up. So I'm going to go b minus a, so I'm going to go 2 minus 1 over 4 times 2, if you're using the trapezoid rule, technically, correct? Because it's 2n. I often memorize the trapezoidal rule as a half change in x and then do the rest of it. I don't do the b minus a. It's the same thing. All right, then we get 1 f of the first one. So f of 1 plus 2. Do I have to show this 1? No, I'm doing that's the point. 2 f of 1.25 plus 2 f of 1.5 plus 2 f of 1.75. Plus f of 2. Only one of them. So we're going to get 1 over 8. Now, I personally don't do f of 1 and f of 1.5 and 2.5 and stuff in the equation. I do it off to the side. I will go f of 1, f of 2. That's a lie. F of 1, f of 1.25, f of 1.5, f of 1.75, and then f of 2. Find those out. This states area under the curve from 1 to 2 of this equation, right? So we just use that equation and plug it into it. So go. Yep. Only have to do the antiderivative if you're doing the fundamental theorem of calculus. This is true. So you're using the original because we're doing area under this curve from 1 to 2. I should not have written these so close together. I'm going to get e plus 2 times e to the 1.25 divided by 1.25 plus 2 times e to the 1.5. And this one you could have just filled in right away because it's more simple, but sometimes it's like a quartic function and it's easier to just find out the answer to the quartic function when you plug in f of 3 than plugging it into the actual formula here. 2 e to the 1.75 over 1.75 plus e to the 2 over Wish the beginning of the podcast would have worked. Start out nicely showing the trapezoidal rule and you guys all being like, what is that? And then look at this. And then you're like, blah, blah, blah. And then we pulled things out. It's like, yeah, there it is. That's how it all went. Except it kept pausing 477 times and freezing on me. 3.062. If you round it, you have to put approximate, which is the little looking like your swimming curve thing.
So I would be doing this with a calculator?
Yes. If you didn't have a calculator, then that would be your final answer.
Okay.
Mrs. Lepp, the practice questions you gave us, are those like actual diploma questions?
Yesterday,
Yeah.
that was, yeah, that was an AP.
Holy crap, that's true.
Wow.
I can do like.
Okay, page 604, 3, 7 to 11 odd, and then page 606, 1 to 3 is the AP question.